Okay, now for the same question, I think it was question number 5 from June 2013, the legacy paper, the R paper. Yes, question number 5. Okay, this is to do with the names of the children. The researcher decides to add a child with a family name Turner to the sample. Now, using the definition that how x varies with x is equal to the sum of the difference between x and the mean of x squared, state the new value of sxx, giving a reason for your answer. Now, basically, Turner, okay, the word Turner has 1, 2, 3, 4, 5, 6 letters in it. Okay, so x equals 6. So the difference between x and the average, okay, the mean is 0. Okay, so the sum of all the terms minus what this represents is for those, there's basically 11 names now, okay, where you're adding together the difference between the number of letters in the name and the average for those 11 names. Now, if you add a name, Turner, to the group, okay, then it has 6 letters, which is the same as the mean. Okay, so it won't make any difference to sxx, because the last term that you're adding all the other x minus x, plus x minus x for each of the first 10 names, plus the last name, okay, it will be 6 minus 6 squared. So you're adding 0 to the sum. Okay, you're adding 0 to the sum. Like the first one would have been x1 minus 6 squared. That's the number of letters in the first name minus the mean squared, plus second name minus the mean squared, plus all the way to the end, right? The 10th name. Then the 11th name now, if it has 6 letters, it won't affect the mean, because it will be 66 over 11. Now you have 66 over 11. Okay, so the mean still stays 6. Okay, and the difference between the mean and that number of letters in the name is going to be 0. So you're going to add 0 basically to this sum. So your answer is that sxx will not change. Why? You can just put because x minus x bar is equal to 0. Okay, so it won't change. This tells you basically how x varies with itself, how how far every term is from the mean. It gives you an average. It gives you like an indication of the sum of all the distances of every term from the mean of those terms. Okay, so here we can see that it will be unchanged because x minus x bar is equal to 0. All right. Now part E says, given that the addition of this child with family name Turner to the sample leads to an increase in SYY, okay, how y changes with respect to itself, okay, use the definition SXY equals the sum of x minus x bar times y minus y bar to determine whether or not the value of R will increase, decrease, or stay the same. Give a reason for your answer. Okay, so now SYY is going to increase. So if you look at R, okay, we're looking at the value of R. R is made of SXY over SXX SYY. Now we know that SXX will stay the same. Okay, so this part doesn't change. Okay, so you have this doesn't change. SYY will increase. That means the denominator is going to get bigger. Okay, so the denominator is going to get bigger. It's going to increase. Right, because it'll be the square root of a bigger number. Okay. Now for the numerator, SXY, what will happen to the numerator? Okay, the numerator, you're going to have, this is going to be 0. Okay, for the next term, the sum of all those, this will be 0, and if SYY, this will increase, so this will basically become 0. The whole thing will be 0 because you'll have 0 times y. Okay, so the last term you add to this is going to be 0. Okay? So you're going to add 0 to the sum. So this will be unchanged. So that will cause R to increase. So R to decrease. That means R will decrease, because you're going to have the same numerator over a bigger denominator. If you divide by a bigger denominator, then there will be a decrease. So R will decrease because the sum of, or the product of s, the square root of sxx and syy is going to increase. Okay, therefore bigger denominator, therefore R is going to decrease. Okay, that could be some of your reasoning there. Okay, so there we have the answer to part E. And that's the question finished.